Hello everybody. Today we are starting our unit on factoring. Factoring is something that you will use through all strands of math and especially moving forward in senior level grades, so it's a very important unit. Feel free to pause these videos and work at your own pace when going through these. I'm going to go through a number of examples through this unit to help you, so make sure that you are understanding, and if you need any clarification then ask some questions. So we're going to start with a warm-up, and it asks us to expand the following expression. So in the previous unit you would have looked at what we call expanding binomials. Okay, so these are two binomials, meaning there's two terms in each of our brackets. I'm going to show you two different methods of expanding, the one that you used in the last unit and then another one that you use only when we have binomials. So in method 1 we are essentially going to do, I'm going to rewrite the problem. We're going to do as you were in the last unit. Well, what does that mean? It means you're going to take first term in your second bracket here, and you're going to multiply it by everything in your first bracket. Then you're going to take that second term of plus 2, and you're going to again multiply that by everything in your first bracket. And then this is simply distributive property here and here. Well, x times 3x, that gives you 3x squared. X times 2, that's 2x. 2 times 3x, that's 6x. And 2 times 2 is 4. Now we just need to combine our like terms to finish our problem. 3x squared plus 8x plus 4. Remembering always to have our highest degree exponent listed first. Now our second method is something that only works for binomials. So anything in grade 10 that you're working like this with binomials will work. It's called the FOIL method. Okay, and these letters stand for first, outside, inside, and last. Okay, so if I were to again rewrite the problem here, so rewriting the problem, and this is how I'm going to multiply and expand these. Well, I'm first going to look at my first term. So the first term in each of your brackets, and that would be 3x and x. So you're going to multiply those by each other. 3x times x, that's 3x squared. Next time you're going to look at your outside terms. Okay, meaning the two terms on the most outside of your brackets, that would be here and here, because it's on the outside. Well, 3x plus 2, that gives you 6x. The next one you're going to look at is your two inside terms. So the two terms in your problem that are most interior is 2 and it's x. If you multiply that, you get 2x. And then the last terms in your brackets. So what are the two last or second terms in each of your brackets? That's 2 and 2. If you multiply those, you get 4. Again, you're just combining like terms. 3x squared plus 8x plus 4. And it gives you the same answer as method 1. So either method is appropriate for expanding, but that was meant to be just more of a warm-up moving forward here. What we are actually doing is factoring. This whole unit is involving factoring and is very applicable to things moving forward, so make sure you're paying attention. So, factoring. First thing we need to do is go over some important terminology, so we know the differences between some of the words that I'll be using and some of the terms that will be within our notes. So, factors are what we can multiply to get a number, and multiples are kind of the opposite, are what we get after multiplying two or more numbers. So if we were to look at an example of 6, and we're only looking at positive factors, so you can get negative factors as well. The factors of 6 are highlighted here and are 1, 2, 3, and 6. Why are they factors? Well, 1 times 6 is 6. 2 times 3 is 6. Okay, those are the numbers that you can use to obtain 6 through multiplication. Now multiples, as we should know at this point, are numbers that you can get multiplying by 6. So, well, 0 times 6 would be 0, 6 times 1 would be 6, 6 times 2 would be 12, and 6 times 3 would be 18. Okay, just to make sure that we have a grasp on the difference between these two terms, we have an example here. Feel free to skip over it if you're ready for factoring. So identify 3 factors and 3 multiples of 36. Well, if I'm looking at my factors, this is all I want to do. Well, you always start with, you have 1 and 36. They're both factors of 36. Okay? Well, 2 times what equals 36? 2 times 18. They are both factors of 36. 3 times what? 3 times 12 equals 36. 4 times 9 equals 36. There's nothing times 5 that equals 36, so 5 is not a factor of 36. And the last would be 6 times 6 is 36. These would be all of the factors of 36. Well, multiples, you always have 0. You can have 36 times 1, 36 times 2 would be 72, and 36 times 3 would be 108. You could continue that list on and on and on as you go through, but we only need 3 examples here. So that would be the difference between factors and multiples. What we're looking at now is factoring. When you're factoring, it means you are essentially dividing or taking something out of your problem. Okay, there's 2 different types of factoring we're going to be looking at today, and each day we're going to add a piece. So we'll do this bit by bit. The first is monomial factors. Monomial, or the prefix mono, means 1. Each of the expressions you're working with has 1 term in it. There's going to be no binomials in these types of problems. So if you look at the first example, 3x squared, that is 1 term. Negative 6x, that's another term. Okay, there's no brackets here. They're just monomials. Factor each of the following by dividing out the greatest common factor. So when you're deciding what the greatest common factor is, you can ask yourself a few questions. 1, are the coefficients, so the numbers involved in your problem, are the coefficients divisible by the same value? Well, our coefficients here are 3 and 6. You can divide both those values by 3, so you could factor out 3. And that's what my first step is going to be. I'm just going to write 3 because that's what I'm factoring out. When it comes to the variables involved in your problem, you want to divide out the highest degree common to each term. Well, the highest degree in our first monomial is x squared, and our second is x. The highest degree involved in our term is just x to the power of 1. So that's all you can divide out. What you're left with, if you divide 3x, or you factor out 3x from a 3x squared, is x. If you factor out 3x from negative 6x, you're left with negative 2. And there you factored your first problem. Okay, let's look at the next one. Well, again, the coefficients here are 3 and 9. You can factor out 3 or divide 3 out from both of those numbers. The lowest degree exponent involved in our problem between our 2 terms is just x, so you can factor out x. And the lowest degree term involved in both of our problems is y, so you can factor out y. What does that leave you with? Well, if you factor 3xy out of 3x squared y, you're left with only x. And if you factor that 3xy out of 9xy squared, you're left with 3. because 9 divided by 3 is 3. And then you are left with y. Okay, and you factor that second problem. Pause the video and see if you can try and factor both C and D. I know they're a little bit longer, but try and identify what's that value you can divide out of all the coefficients, and what is the lowest degree involved in each term that you can factor out of every term. Okay, now that you've taken a shot at it, let's go through these. Well, 12, 8, and 16, what is the greatest common factor that you can divide out of 12, 8, and 16? Well, the greatest common factor is 4. Okay, now you notice each of these terms has an a involved, but each of them also has their own variable. This has b, this has c, this has d. You're not going to be able to factor out b, c, or d because it's not common to all of the terms. However, a is common, so you can factor that out. What does that leave you with? Well, if you divide 12 by 4, that's 3. And remember, you still have that b involved. 8 divided by 4, that's 2. And you still have that c. And 16, or negative 16 divided by 4 is negative 4. And what are you left with? You're left with d. And you factor that problem. Okay, and the last one here, same thing, you're looking at 8, negative 6, and 4. What is the greatest common factor that you can divide out of all of those? That would be 2. Now, is there variables in common with these? If you notice, the lowest degree term that you can take out for x is x squared. They each have at least x squared involved in their term, so you can factor that out of all three of them. And you notice that this first term does not have a y or a y squared variable, but the next two terms do. You're not going to be able to factor that out here because it's not common to all three terms. It's only common to 2. So if you factor out 8 divided by 2, that's 4. And then if you factor out x squared from x cubed, you're left with x. Okay, well, negative 6 divided by 2, that's negative 3. If you factor out x squared from itself, it's 1, so there's no x involved here. And you're left with that y squared. 4 divided by 2, that's 2. Again, you factored x squared out of itself, that's 1, so you don't need to rewrite that, and you're left with just y. And there you have it, you factored that problem. So those would be binomial factors. The next one would be binomial factors, and binomial means you're working with expressions that have two terms. The prefix bi means 2. Okay, so sometimes those prefixes in math will help you identify kind of what you're looking at. For this problem, it says example 3, factor the following binomials by asking yourself what is the same and what is left over. For this first problem, you have two terms. Although it looks like more, this is one term because it's all together via multiplication, and this is another. If you look at those two terms separately, what do you see that is common to them? Well, you notice that they both have this 3x minus 7 and this 3x minus 7. So you're going to factor that out. And that's the portion of what is the same as I'm asking you. And just simply rewrite that. 3x minus 7. If you take away both that 3x minus 7 here and 3x minus 7 here, so you factored it out, what do you have left over? Well, in the first part you have 4x. Right? And here you have 3, positive 3. And you factored that. Okay? Again with the next one. Well, here's your two terms. What is common amongst these two terms? 2x minus 3, 2x minus 3. Rewrite that. 2x minus 3. If you factor that out, what are you left with? 2 plus x. Okay, these ones follow a pattern every time, so you can continuously factor these problems the same way. Take a look at C and D and try and come up with the answer right now. Okay, again, we have two sets of terms here, 1 and 2. Okay, Well, what's common to both of these? 2x minus 7, 2x minus 7. That's what you're going to write down here first. And what do you have left? Well, you have 2x and this value right here in front of the brackets. And you should know that in math we don't write the number 1 when we have that there, so it's negative 1. And you factored that one. And finally, for the last one here, what do you have that's common? X minus 4, x minus 4. If you get rid of that, what is left over? 2y minus x. Okay, that is your first experience with common factoring. Make sure you do the questions for this section because it's very important to understand common factoring before you move forward into more complex scenarios. Just as a summary here, you looked at expanding in the last unit and you just got your first taste of what factoring is. Factoring is the opposite of expanding. Expanding involves multiplying and factoring involves looking for values to multiply. So if you have one problem, you have 4x bracket 2x minus 3. If you were to expand that, so 4x times 2x and 4x times negative 3, you would get 8x squared and negative 12x. Now if you were going to go the opposite way and you ask yourself, well, what is the greatest common factor that I can divide out of 8 and 12? Well, that's 4. They both have x in common. Okay. If I divide or I factor 4x out of both of these terms, what am I left with? I'm left with 2x minus 3. So this is sort of a repeating cycle that you could go in, and it's a way that you can check your answer. So if you factored something and you want to know, did I factor it correctly? Well, expand it and then see if you get back to the original question. Okay, to check factoring, expand your problem to see if you get back to the original question. Alright, that's it for common factoring. Be sure to do those suggested exercise and ask for any help if you need to.